change.
Right. So that means around, around us, everything is changing, right? So every day the money value is changing. Every day the petrol rate is changing. Every day that gold rate is changing. Every day, the money inflation, right? So that is everything is changing around us, right? So those things can be easily predictable by using the calculus, right?
Yes.
That is what the mathematics began the changing concept. That is, so we used to code. We have a codes in the world. That is, changes are always constant, right? So did you see this code? Code changes are always constant. Did you ever come across this code? Changes are always constant. Did you?
No.
Yes. No. Okay. So you have to remember this is very, very one famous quote. Okay. So people will always quote when you are going for higher studies. Okay. Anyway, so changes are always constant. That means தமிழ்ல சொல்லுவாங்க மாற்றம் ஒன்றே மாறாதது அப்படின்னு. ஓகேவா? Right?
Okay.
So that if you want to predict the changes, then you have to go for which mathematical language? You have to go for calculus, right? So that's why this calculus is called mathematics of all things that change. Okay, right? Who found this calculus? Who found this calculus?
Newton and someone.
Leibniz. Someone, don't call someone. So Leibniz, Newton and Leibniz, right? So both of them are scientists, right? So they have developed during 16th century, right? Right. So this is what now. From which idea they are finding this? From which idea they are finding this? They know that as they are moving from the Earth's surface, the gravitational forces decreases, right? So as the distance increases, the gravitational forces decreases, right? So based on that concept only, this calculus comes into the picture, right? Yes.
Yes.
Right. Okay. So these are all the things we have seen, right? Slope, gradient. So that again I will tell you today in a detail. Slowly we will see. Okay. I don't know whether the previous class lecture have been fruitful to you. Okay. Again we will teach this slope concept, gradient concept, tangent concept, everything I will retaught. Okay. Right. Then we will see some of the new topics. Okay. Yes. Right. I think this are all I have shown you, right? Last class. Gradient means, what is the meaning of gradient? Gradient means rise over run.
Yeah.
Remember this?
Yes.
So this is what gradient, secant, everything we've seen, right? So same thing, we can see it is the sum of the more idea, right? Okay, fine. Okay. So let me very slow, right. So let me take it into a very, fun way, right? Okay. So tell me, see, you are running. See, for example, on athlete, do you watch? Sports.
Yeah.
Do you? Which sports you are more interested with?
Tennis.
Tennis, right? Okay, right. So tennis. Do you aware about cricket? Cricket.
Yes.
Yes. Okay. Who is your favorite cricketer? Indian batsman or bowler?
அதெல்லாம் தெரியாது.
I don't know anything.
அவனுக்கு கிரிக்கெட்னு ஒரு கேம் இருக்குன்னு தெரியும், அவ்வளவுதான்.
Right. Okay. Right. So we can talk about tennis. Whom do you like the most? Tennis.
Roger Federer.
Roger Federer. Right. Okay. Rafael Nadal don't like, huh?
Huh?
Rafael Nadal.
Yeah, I like Nadal, Djokovic. Yeah, I like them.
Djokovic also you like, huh?
Yes.
Right. Okay. So we can consider those person. Okay, Djokovic. Okay, fine. Okay. So these are all some tennis player, right? So now they are taking some. Always the tennis player taking some warm up game, right? Some warm up game they take. Before that, they used to run throughout the ground. Okay. not inside the tennis ground, right? Outside the tennis ground, they used to run before they are coming for the match. Okay, right. So let me consider Roger Federer is running, right? So Roger Federer is running right now, and he wants to reach 100 meter, right? He needs to complete 100 meter, right? So if he wants to complete 100 meter, then he took. So let me consider. If you want to complete 100 meter distance, then he took some 10 second. Okay, so let me consider it. Okay, so this is my assumption. Consider. Okay,
Okay.
so
Okay.
and if you want to complete 100 meter, then he took 10 second. Okay, this is the first day. Okay, so this is the first day. Then the second day, same 100 meter he is running. Okay, same 100 meter he was running, right? So if he wants to complete the same 100 meter distance, then he took only 8 seconds. Let me consider it. Let me consider 8 seconds. Okay. The third day, Roger Federer is running, right? So Roger Federer is running, and he wants to complete same 100 meter, but he took only. For example, let me consider he took 12 seconds, right? So in each and every day, the changes are happening, right? With respect to the speed, the changes are changing, right?
Yes.
Changes are happening, right?
Yes.
Right. Now what I am coming to say is that now tell me in a simple manner. See here, what is the 100 meter? What is the term 100 meter is called here? As per this, what is 100 meter? Is it called a? Can I call that as the distance?
Yes.
This is the distance to be covered, right? And what about this one? This is the time taken for him to attain the 100 meter, right? So this is the distance and time, right? So based on which we can calculate one famous parameter. What is the parameter? If you know the distance and if you know the time, then we can calculate something called what?
Speed.
Very good. Speed. Very good. Speed. What is the meaning of speed? Distance
Over time.
Right. So now Roger Federer is. Let me consider the first example. So let me consider the first example. Okay. Right. So Roger Federer is Federer wants to complete 100 meter distance mean during the first day. How much time he is taken? Distance over time. Distance over time. How much
10
time he
seconds.
took?
10 seconds.
Right. That means if you want to complete 100 meter distance, then he took 10 seconds. Understand how do I rate it? 100 meter for 10 seconds. Okay. Tell me the same value in terms of hours. Instead of seconds, meter per second, right? 100 meter per second. The same thing, tell me in hour. How many seconds can form hour? 1 second, 1 minute.
3,600.
Right, so very good. So 1 second means you have to divide it by how much value? This one, if you want to convert it to 100, what you will do? You have to, what you will do? Just divided by 10 is already there. What is the value? 100.
100.
Which value will be multiplied? Multiply or divide it?
Divide.
Yes. Divide. Which value you have to divide it?
By 100.
100. Why 100? See, here 100 by here. So meter, instead of meter, let me consider R, right? Seconds. So 1 second equal to how many hours? 1 hour equal to how many seconds? 1 hour equal to how many seconds? You only told me.
3,600.
Hertz, right? So tell me what is 1 second. 1 second, can I assume 1 divided by 3,600 hours? Yes?
Yes.
Instead of putting 1 second, let me put 1 by 3,600 hours. Can I put like this?
Yes.
So what I can do? So instead of this, so let me erase this and then tell you. So this I am leaving it. Okay. So now what is my job? I want to convert into a right. So now this is 10. So if you want to convert seconds to hour, which value you have to multiply? You have to multiply 1 divided by 3,600. Understand what I am writing? Yes.
Yeah.
Right. Here only you have to do the multiplication of 1 by 3 600. Don't put it at the above one. Okay. So now here some values there. So now tell me what is this? 100 divided by 10 into 1 by 3600. What is the value?
1 over 360.
That is some values there. Okay. So let me finish it. So 10 divided by 3600 is 2.77. Here the value is 2.77 into 10 power minus 3. Do you know what is the meaning of it? Yes. What is the meaning of 2.77 into 10 power minus 3? Do you know?
No.
No. Okay, fine. So let me make it into with your easier way of representing. Let me consider. I mean, if you are dividing 10 over 3600, right? So you know how to do the division. 10 over 3100, right? You know how to do it, isn't it? Yes.
Yes.
0.00277. If you want, you can do it. How do you do the division? 10 over 3600, right?
Yes.
So if you want to put, you have to put dot, right? 0 point. You have to put, whenever we are putting chart, you can add one extra 0, right?
Yeah.
Then is that 100 is divisible by 3600?
Yes.
No. So you can
I
add
know.
one more 0 here, and you can add one more 0 at the quotient, right?
Yeah.
Yes or no?
Yes.
Now is that value is still? I mean, is that
No.
still is divisible?
No.
No, right? What you will do? You will add extra 1 0, and you will add extra 1 0 here also, isn't it?
Yes.
Now tell which value you have to put here. Which value you have to put? Can I put? Is 10,000 is divisible by 3600?
Yes.
So which value I can put? I can put the value 2, right? So what is the value? 2 into 3600 is 7200, right? So what is the remaining value? What is the remaining value? 2800, right?
2800.
So next what you'll do? You will add extra 1 0. Here afterwards there is no need to add it, right? So extra 1 0 you are adding, right? Extra 1 0 adding. Now you have to do now you have to check it out. By multiplying which value with 3600, you are going to get 28,000. That value is 7. 7 into 3600 is what? 7 into 3600 is 25,200. Okay. Yeah, I know the value, that's why I am putting, right? So likewise, you have to do the process, right? So if you are getting, then the answer is 0.00277. Understand?
Okay.
So now what you have to do? Again, you have to divide 100 over which value? So this is nothing but 100 meter per hour, right? So again 100 you have to divide by which value? 100 divided by this one. What is the answer? 100 divided by 0.00277. The answer is 36,101.08 meter per hour. Okay?
Okay.
Right. So now tell me the same thing in terms of kilometer. Tell me how do you convert this meter into kilometer? How many meter can form a kilometer? This is very
1000.
How many meter?
1000 meter.
1000 meter can able to form a 1 kilometer, right? Very good. So that means here 36,101.01 meter is there. So that I can make it into 36.101 kilometer per hour. Kilometer per hour. Understand? So now, earlierly I am telling with respect to the distance and time. I mean, Federer wants to complete 100 meter distance. He took 10 seconds time. The same thing now I represented in which parameter? Same thing. Speed. So what is the formula for speed? What is the formula for speed? Distance over. What is the formula for speed? Distance over time. Right? So here for 10 seconds, I mean, if you want to complete 100 meter, then he took 10 seconds. Same, instead of representing in second, they are representing in hours and kilometer. Understand what I am telling? Yes?
Yeah.
Right. So this one. So now you have to remember, instead of representing the values in distance and time, we are representing with which parameter?
Speed.
We are representing the parameter speed, right? So if we know distance and speed, we can calculate speed, right? So that is what I'm telling, right? So now, so can you tell me likewise, instead of telling in terms of 100 meter, he travels 10 seconds, 100 meter instead of 8 seconds, 100 meter 12 seconds. Instead of telling like that, how can you quote it? Instead of telling, if he, in the first day, he took 10 seconds to complete 100 meter, second day, he took 8 seconds to complete 100 meter. Instead of telling like that, how can you say? First day, he ran with the speed of how many kilometer?
10.
Per hour. Not 10. How many kilometer per hour? Here you can look at and tell me. 36 kilometer per hour.
Okay.
During the second day, how do you calculate the value? Can you tell me? How do you calculate it?
100 divided by 8.
8, right? So like this, you have to calculate. So that value may be, definitely that will be increasing, right? So there will be a 40 kilometer per hour, okay?
Okay.
Second day, he may run at 40 kilometer per hour. The third day, he ran at 100 meter with 12 seconds. So 100 by 12, right? So definitely that value is smaller than 36. So it may be 30 kilometer hour. Sorry, not smaller. That is somewhat. Yes, 30 kilometer per hour. Okay. Understand what I'm telling? So
Yes.
if you are given with distance and time, you can't able to. I mean, every time you don't need to quote this much amount of distance he ran, this much amount of time he took. So don't tell like that. Okay. Instead, you can quote with the term called which one? Speed.
Okay.
Right?
Yes.
So that is what I'm saying, right? So this is the speed. Okay. Why, sir, this speed is very important is that, so this is what I have told you. Yesterday, last class, I have told you that speed, slope concept. Did you remember it? Slope, gradient. I don't think this gradient. Did you remember this? This one. The slope, run over, rise over,